Bonjour, merci de participer à cette 12e journée de DataXDays. Le prochain talk sera en anglais, alors I'm switching to English right now. Next talk is we are going to talk today about delta lake, and we are going to talk about data science. Thanks for coming for the second day of DataXday. We have a date every Tuesday of June. This month we already talk about DataOps, and now is the time to the data science and Spark. We are going to start with data science. I have the pleasure and the honor to introduce you Daniel Whitenack. He is a data scientist creating AI for Good with SEAL International and co-host of Practical AI FM. He's going to talk about AI for every language. Thank you, Daniel, and the public is yours.
Thank you very much, Diana. I'm very happy to be here and thankful for you for letting me join into this great event. As was mentioned, I'm Daniel Whitenack. I'm a data scientist with SIL International. If you're not familiar with SIL International, it's an international faith-based nonprofit. Our mission is to help people flourish in community with the languages that they value most. And that, of course, involves a lot of things because pretty much everything has to do with language. So we do translation work, but we also do literacy and language development work. We have consultative status with the UN for language-related issues, but also helping people flourish in community with the languages that they value most has a lot to do with technology. And so we also have technology efforts. We support the Keyboard Keyman, which supports over 1,000 languages for keyboards on mobile devices and other devices. We also maintain a data product called Ethnologue, which gives information about all of the languages of the world. But I specifically work at the intersection of AI, or artificial intelligence, and local languages, and that's what I'll be talking about today. I also co-host the podcast Practical AI. If you're into podcasts, I definitely recommend checking it out. We've had some great guests over time from the big players in the AI space, from NVIDIA and Google and OpenAI and others. And I know I've learned a lot from the podcast, and I think it would be a great resource if you enjoy that format. Today, what I'm going to do is I'm going to start by just talking about artificial intelligence for language, or what some people call natural language processing, or NLP. I'm going to talk about the sort of common tasks that people associate with NLP and why people are giving a lot of attention to the subject these days. Then I'm going to turn to talk about current language support in NLP tasks and why it's important that we extend that. I'm then going to talk about some good trends and some great work that people are doing to extend AI to every language. And then I'll round out with some demos and some conclusions and resources. So first, let's talk a little bit about AI for language in general, or what people call natural language processing. Now, many of you interact with these sorts of technologies on a daily basis. You may not know that, or you may be very aware of that. Probably one of the things that you're most aware of or comes to mind immediately is translation technology, like what's in Google Translate. So if I want to translate a piece of text in one language to text in another language, this is called translation or machine translation, and is maybe the first task that people think of when they think of natural language processing. But also another kind of set or collection of tasks that people think of probably very frequently in relation to natural language processing are those related to dialogue or generating responses in some sort of assistant technology. Maybe you've interacted with a customer service chatbot, or you have an Alexa device or a Google Home, and you can give make a request to that sort of device or that sort of application and get a response, and do that in a very natural text or natural speech format. And this all fits under the category of dialogue. Now, there's a lot of things involved in generating a response, like in a chatbot type of application. And let me kind of dive into a few of these sort of subtasks. One of those is called natural language understanding, or NLU. So if I type into my chatbot that I want to order a pizza, the natural language understanding task would be the task of categorizing that input into one of a series of what's called intents. And these are basically classes. So if I say, I want to order a pizza, then what I'm intending to do is make an order of food. And so that's a certain class of text. And so really, this is just a special case of what's called text classification. And you could think about this as categorizing that into a class of food order. Now, along with understanding the intent of text, another thing I may want to do if I'm taking an order for food is to actually understand not only that they want to order food, but what food they want to order, right? And this is called named entity recognition. And so named entity recognition has to do with taking a piece of text and actually extracting some entity from within that text, and both determining what the entity is and what value of that entity it is. So here I'm wanting to order a food item, and that particular food item is pizza. Now, this certainly isn't only relevant to dialogue, but it certainly is used very frequently in dialogue systems. Another sort of task that is very relevant to dialogue is what's called sentiment analysis. So in sentiment analysis, what I'm trying to do is actually take a user's input or some piece of text, maybe a tweet or something like that, and determine if it's kind of slanted towards a positive sentiment or negative sentiment. So here I could say, I love pizza, it's so great, and that has a high sentiment value. Maybe my sentiment goes from 0 to 1, and this is a 0.95 sentiment. Whereas if I said, I hate pizza and it's so bad, although I don't know why anyone would say that, then the sentiment might be very low, like 0.1 or something like that. And so sentiment analysis is trying to get this sense of sentiment in an input text. Now, not all language is represented textually. We actually speak language like I'm doing now, right? And so other NLP tasks have to do also with speech. So I could think about taking an audio signal and then figuring out what is said in that audio signal, or transcribing that audio signal from the audio signal into text. And that's what's called speech recognition, or automatic speech recognition, ASR. I could also go the other way, right, and go from text to an audio signal, or generate a synthetic voice that says some text. And that's what's called speech synthesis, or text to speech. And both of those are utilized very heavily in like our smart assistants that we like, or maybe Siri or our assistant on our phone. Also, if I'm interacting with a user, a lot of times I don't just care about, understanding what they're saying, but maybe I'm trying to be useful to a user. And when I'm interacting with them in a textual way, I might want to give them information. And so another task that's very common in NLP is to take an input question and try to answer that question based on some external context or supplemental information. So a user might ask, where was pizza invented? And I could use the Wikipedia article for pizza and maybe extract that it was invented in Italy and supply that back to the user. And this is generally called reading comprehension or machine comprehension or question answer. And there's a variety of flavors of this itself. Finally, I might just be interested in understanding more about the text itself that is input to me. And so I could take this statement, I love pizza, it's so great. And I could actually determine, what are each of these pieces of the statement? What is their role in the statement as a whole? Some of them are going to be verbs, and some of them are going to be nouns, and some of them are going to be punctuation. And so I could do what's called tokenize this text into its various pieces, like I and love and pizza and comma and it. And I could assign a tag or a part of speech tag to each of these series of things. And this is called, as you might guess, part of speech tagging. I could go a step further then and actually determine what is the relationships between the various things in my sentence in a grammatical way. And this is what's called syntactic parsing or dependency parsing. And the output might look something like this. Okay, so that's a kind of very brief introduction to common NLP tasks. This is by no means a comprehensive list of tasks. There's many more things that people do when they process language, but this is kind of some highlights. And this brings up the question, actually, these tasks have been around for some time. So why are we really talking about AI for language right now? And it seems like a lot of people are talking about it. In fact, one of the reasons why I've been looking at the intersection of AI and language with SIL is the fact that there's been a huge amount of attention placed on natural language processing by industry professionals, but also the research community over the past couple of years. That's reflected in this statement by a VC, Jay Alamar, who talks about 2018 and the sort of following years as being an inflection point for machine learning models that handle text. And if you remember back to like 2010 or so, all of these like new AI methods came about to process images or video. Generally call these computer vision tasks. And computer vision kind of had an inflection point back in those early days of deep learning, back in sort of 2010 and on, where a lot of new developments happened in the computer vision space. And what Jay is saying here is that 2018 and on is kind of this golden era of a lot of effort and attention being placed on natural language processing and the corresponding AI models that are performing these sorts of tasks that I've described before. And so we're in kind of a special season. There's something special happening with natural language processing right now, which wasn't happening before. And that begs the question, why is this happening now? Why are things happening now in AI and natural language processing where they weren't happening before? And so I have my own perspective on this that I'd like to share. And I think there's many, many reasons why this is the case, including, the availability of compute and data and all of those things. But there's also, I think, a more fundamental reason why there's been this interest. And that's because prior to recent times, if I wanted to solve this task of sentiment analysis, where I take in my input text that I love pizza, it's so great, and I want to guess a sentiment from this text. I want to guess, 0.95 or a high sentiment. Well, the way that I would do that in a quote unquote more traditional way is that I would create a rule-based sentiment analysis predictor that utilizes a bunch of linguistic information about sentiment to guess the sentiment of this statement. And so this linguistic information, maybe it includes a a lexicon or a vocabulary of sentiment type words like good and great and bad and horrible, and various rules about, like, if one of those words comes before a noun, then I'm going to mark that as a good sentiment corresponding to this aspect of the noun. And so there's ways to create this sort of sentiment analysis system using this expert linguistic information about sentiment. Now, the interesting thing is, if I then, say, all right, that's great, I can do sentiment analysis in this way, but now I don't want to do sentiment analysis, I want to do a different NLP task. Let's say that I want to now do the task of machine translation. I want to translate that statement into French. Well, I could do the same thing. I could create a rule-based machine translation system, but the linguistic information and the rules associated with doing that translation are going to be almost entirely different from those that are related to sentiment prediction, right? And so I need this sort of unique curated set of expert linguistic information and rules to translate from language A to B that are very different from the rules and the information that's required to do the sentiment analysis. And so there's a lot of work, there's a lot of expert input that needs to happen when it comes to doing this sort of thing with machine translation versus the previous thing with sentiment analysis. Now, in the last couple of years, what we've, and this is happening before the last couple of years, but really in the last couple of years, this new sort of way of thinking about these problems has developed. And that is that we're now trying to generalize this set of problems into a specific sort of templated way of thinking about doing natural language processing, which looks like this, where I have a machine learning or artificial intelligence model. And these sorts of general purpose machine learning models or AI models like neural networks, what they do is they take in input numbers and they output numbers. That's basically the input output structure of any of these types of models. Is they like to take in input numbers and they like to output numbers. And there's a whole variety of general purpose machine learning models that I could use in there, like, neural networks and various flavors of neural networks, like recurrent neural networks and convolutional neural networks. But they all kind of have this structure, and the layers in those models are reusable. And so I might now think about my sentiment analysis problem in this way, where if I was able to map my input text to a set of input numbers, then I could use one of these general purpose machine learning or AI models to output another number corresponding to sentiment. And this sort of first step of getting that text into input numbers is what might be referred to as encoding. And so now what I've done is I've mapped the sentiment analysis problem onto this template of a general machine learning problem that it is dependent on some encoding methodology. And the nice thing about that is you can see in this picture, I no longer have any linguistic information that's entering or rules that are entering the scenario. Really, all I need to train this sort of model is a bunch of sentiment data with input text and the corresponding sentiment that I'd like to predict. And if I have that raw data, then I can train this sort of machine learning model really without linguistic information or expertise in sentiment. I can just plug the data in, train the model, and then have a model that works for sentiment analysis. And what's really cool is that I can now take this same templated structure and move it to various other NLP tasks. So in the case of translation, it might look something like this, where I have an input text, which is again encoded, a general purpose machine learning model or AI model, and then I have a set of output numbers, which is then decoded into my output text. And so I could actually reuse that general purpose machine learning structure or architecture to train a machine translation model now. And again, I've decoupled this task of machine translation from a lot of linguistic expertise in translation. So if I have aligned pairings of input text in one language and output text in another language, then that's really all I need to train a machine learning model. I no longer have to be a linguist to do this. I just have to know how to prep my data and train this model. And of course, this could be transferred to various other NLP tasks like part of speech tagging and named entity recognition and a variety of other things. And so now I'm no longer thinking about sort of expert ways of crafting specific sentiment analysis algorithms or specific translation algorithms, but I'm thinking about general purpose machine learning models and gathering data. And a lot of the emphasis is put on the data. And so that's these powerful components that Jay Alamar is talking about. Is over the past couple of years, people have increasingly developed these more and more powerful general purpose machine learning and AI models that, paired with the right input and output data, give us great power and flexibility to solve a whole variety of natural language processing tasks. And that's really exciting because now I no longer have to be a linguist to do natural language processing things. I just have to, know how to import TensorFlow and get my data into the right shape and train my model. And that was really fun for me to learn and experiment with when I was first getting into this, is training, a machine translation model that does quite well at translation. And I don't even know the target language, or I don't even know a ton about the linguistics or the grammar of each case. But because I'm using this powerful machine learning component, I'm able to now complete these sorts of tasks in a very quick way. So that, from my perspective, this is a kind of shift that has happened recently. And that brings us to talking about language support. So if the industry in general, and if the research community in general, has made some great strides in generalizing NLP tasks to this framework of machine learning, then hopefully we've also made some strides in terms of supporting various languages, because now we just need to gather the right data for the task. However, if we look at common NLP tasks like we've already talked about, so if we look at sentiment analysis and syntax analysis, named entity recognition, text-to-speech translation, and automatic speech recognition, and we look at the number of languages that are supported in kind of major platforms for these things, where there's commercial offerings of this technology. So these include places like Google and Microsoft and Amazon and Yandex and a bunch of others. You generally see this range of numbers. I won't say which of those platforms I got these from, but I got them from one of those platforms where for sentiment analysis and syntax and NER on the low side, we have support for about 10 languages. And on the high side, for things like translation and automatic speech recognition, we have support for about 120 languages on the very top side, right? And don't get me wrong, these companies and these groups have made great strides and put in a lot of effort into expanding the language support for these sorts of tasks. And I give them a lot of credit for that, and they've done a great job. However, if we take a look at this in relation to the global language situation, we're kind of blown away by something almost immediately, which is the fact that currently in our world, there are being spoken right now around the world 7,117 languages. And if we plot that total number of languages versus the language support for each of these pieces, you can see that in some cases, the support is almost negligible or a drop in the bucket, right? And so we actually have a very long way to go in terms of adding support for languages for these AI tasks that are really driving a lot of the technologies that you and I are using on a daily basis. And I should note that these, when I'm saying 7,000 languages, these are actual languages that are living, that are spoken around the world, not dialects or anything like that. And there's even more if we're thinking about sign languages and other things, and we include dialects and those sorts of things into the mix. So the question comes up, if we're talking about this, what makes this an important problem to address? Why is the fact that there's such an imbalance here something that's important to address? Can't people just use, the most the best languages, or the most highly used languages? And that's definitely not our viewpoint at SAL. But if you don't trust us or me, I think a good reference here, maybe that some of you are familiar with, is Francois Chalet, who is a researcher at Google and also the creator of Keras, which is the actually default API in TensorFlow now. And he talks about this sort of long-term cultural and linguistic dominance of the Anglosphere in natural language processing, and the fact that these models that are being created, these powerful components that people are training, are actually cutting off local languages and cultures from the next generation of AI applications. And so if you think about our daily life and the things that we are privileged enough to experience, like being able to use Google Translate as we travel to certain places, or being able to have autocomplete in our Gmail, which is now we take for granted, or even something as simple as Google Search. Google Search now is driven by a large-scale language model called BERT, which is used every time you do that Google search. And so these are things that have become standards in our life of how we interact in the digital sphere. And for communities around the world that are actually already marginalized because they maybe don't speak the majority language for their country, and maybe they're already even persecuted for their cultural identity, and then we add on top of it that we're not giving them the same benefit from these AI applications that we're getting, it's actually only making them further marginalized. And this is definitely a problem, and something that we really need to put some focus in and try to address. Although if you're not convinced by the sort of moral or social good argument or side of this thing, there's another way to look at this as well, which is the fact that actually the largest emerging markets and fastest growing economies of the world are places where there are a lot of languages that are spoken. So if I look at Brazil, I'm looking at over 200 languages that are spoken in Brazil. Or if I'm looking at Indonesia, which is just a huge emerging market and a fast growing economy, there's already, there's over 700 languages spoken. And so now that companies are becoming more and more globalized, it behooves them, as they're entering these emerging markets, to think about the language situation. If they can have an edge in terms of support for languages and integration of local languages into their applications, then that's going to give them an advantage over other applications, other companies' products that is actually really important and might make the difference for entering those markets. And so even just on an economic scale, if you're not considering the language situation around the world, and if you're thinking that, a couple languages will be good for me, then you're really leaving money on the table, essentially. And so this is another reason that we really should be thinking about AI for every language, not just for the major languages or higher resourced languages of the world. So hopefully some of that has convinced you that this is an interesting route to go, and that we should be thinking about AI for every language and not just AI for higher resource languages or widely used languages around the world. Now let's actually talk about what is occurring in the research world, in the AI world, that's actually maybe giving us a chance to extend AI methods to every language. And actually, there's a variety of groups around the world, both in industry and in academia, that are making some really great strides towards methodologies that will help us extend AI methods and NLP methods to local languages. And so I want to highlight a few trends that I've seen there that are really encouraging for me and that I'm really excited about, and encourage you to look at and to explore a bit as well. If you want to learn more about these sorts of techniques, I've actually created a link here to a workshop that some researchers at Carnegie Mellon University put together, that actually goes through a lot more detail about all sorts of methods for lower resource or local language NLP. And I would encourage you, if you're particularly interested in this topic and interested in contributing, that's a great starting point to learn more about the things that I'm about to talk about. So just as a reminder, this is our kind of basic template of modern NLP, where we have a general purpose machine learning model that processes input numbers and output numbers and creates output numbers. And what we're reliant on here is a bunch of example data, example raw data that represents our input and our output. In the case of machine translation, for example, that could be a bunch of aligned pairings of input language and output language for the same statement. This is what's called a parallel corpus. But in other cases, like sentiment analysis or named entity recognition or text classification, the data set's going to look different. But in general, it's true that to train one of these models, we need a large amount of this sample raw data. For example, for machine translation, for kind of a good machine translation model, we might be looking at, 5 or 10 million samples of aligned input data to output data. And so that's quite a large scale of data. And so immediately what we're struck with is the fact that for a lot of local languages around the world, this sort of longer tail of languages, we just don't have that much data, right? So if I look at a language like Solomon Islands Pidgin, which is spoken in the Solomon Islands, I really just don't have a lot of data for that language. And it's certainly not of the scale of millions of samples. It might be of the scale of tens of thousands of samples, if I'm lucky. But it's a vastly different scale. So how do we deal with the fact that we don't have as much existing data for these languages? What sorts of methodologies can we apply to help push AI technology into the sphere of local languages? One of those things is called transfer learning. Transfer learning is what I would consider the sort of bedrock or foundation of all of modern AI, really, even past language into things like computer vision and other things. And the idea of transfer learning is that we can kind of stand on the shoulder of giants, in the sense that if an existing model has already been trained to do something very similar to what we want to do, then why throw away that knowledge about that related task when we're trying to learn about the task that we're completing? And in transfer learning, you actually don't throw away that knowledge. You would pre-train a base model on a large set of data. And then when you train for your particular task that's related, you don't start from scratch. You actually initialize the parameters of your model, the weights and biases of your model, with that set from the base or parent model, and then actually just fine tune the model with a small number of samples from there. So let me give an example to make this a little bit more concrete. let's say that I wanted to create a machine translation model for an Arabic vernacular, like Egyptian spoken Arabic or Moroccan spoken Arabic. Well, there's not a ton of data that I have access to for those vernaculars, but I do have access to a lot of data for standard Arabic. You can get that from a variety of places that are all open, and I can get millions of examples of English to Arabic aligned data. And so if I think about this in a transfer learning setting, I have maybe a base or parent model that I can train on the task of English to Arabic translation. And that's very related to the task of translating from English to the Arabic vernacular. And so I could pre-train a base model on that English to Arabic data, initialize a new model for my vernacular, but initialize it with that base model and learn on a smaller number of samples for my vernacular. And this has actually proved to be quite useful for both machine translation, but other tasks as well, including, sentiment analysis and text classification and part of speech tagging and all sorts of things. Is this idea of standing on the shoulders of giants. And in some cases, you don't even have to pre-train your own model, your own base or parent model. You can get that publicly from places like TensorFlow Hub or PyTorch Hub, or a GitHub repo that has published a pre-trained model from a certain paper. So this is a great technique that is kind of in the toolbox of extending AI to local languages. A next thing is what's called multilingual models. As it turns out, we could think about certain tasks like text classification or machine translation in terms of a single language. Like, oh, I'm going to translate English data, or I'm going to get the sentiment of English text. But you could also think about those tasks in a multilingual manner. In other words, I could combine data from multiple languages in the training of a single model. And what that might look like is for, let's say, named entity recognition. The first row in my training data is an English statement, and the paired target is entities that were extracted with English. In the next sample, I have a German statement, and the entities extracted in German. And then the next sample, I have a French example, and the entities extracted in French. And this is actually all concatenated together to train a single model for that task. And Google has done a lot of work in this area. Many others have done a lot of work in this area. And what they've shown is a couple of interesting things. First of all, the internal representations of the text in those cases, which are called word embeddings, which is a numerical internal representation of the input text, as I mentioned before in that template that we talked about. Those actually allow you to, the way that those are trained allows and kind of automatically pops up the linguistic structure of all of those languages. And so the model is actually learning how languages are related internal to the model's parameters. In addition, they've showed that maybe for a high resource language like English, you don't really get that much benefit from creating one of these multilingual models. But for a low resource language, let's say the Solomon Islands Pidgin again, you could actually get a huge benefit from training one of these multilingual models to do your task rather than just training on the data that you have access to for a particular language. And this is really intriguing because what it's basically helping us see is that our models could actually learn about language and language families and grammar and syntax generally for all languages and help us kind of reduce the burden of adding in new languages into our systems. And this is actually how a lot of machine translation efforts are happening now, is with these multilingual approaches. Next, something that has been pretty key, I think, to boosting low resource NLP performance on local languages, it is a set of unsupervised or semi-supervised methods. And what I mean by unsupervised is the fact that, let's go back to our example of Solomon Islands pigeon. I might have 10,000 aligned examples of my input text to my output text. And that's the training data that I have that's labeled and annotated. But I also have unlabeled data, maybe a monolingual source of Solomon Islands pigeon data that's like a book or literacy materials or something like that. And there are now unsupervised or semi-supervised methods that will let you both leverage the aligned annotated data plus unaligned unannotated data or monolingual data, and use that monolingual data to boost your performance in something like machine translation. And one of the methodologies to do that, I stole a picture from here, which you can look a little bit more at the provided link. But it's really fascinating what was done in this link. They actually did unsupervised machine translation. So in other words, they assumed that they had no aligned parallel data between English and Urdu. And they only used monolingual data from both languages and still used this unsupervised method to align the two samples and or the two language collections of language data and train a machine learning or machine translation model. And so this shows some great progress. And I think in a lot of the shared tasks for AI and machine translation now, these unsupervised methods, which you might hear people refer to as unsupervised or iterative back translation or utilizing monolingual data, these are kind of a key piece of the puzzle in how to solve these problems. The final great trend that I love seeing is the fact that now there's a great open source community around AI methods and particularly NLP. Here's an example from Hugging Face, which you probably know, especially if you're in Paris, as Clem is I don't know where he's at now, but I know he spends time there. And what they did recently, I forget the date of this, but they're always releasing these sort of new models in their open source framework. Here they were releasing translation models that are covering more than 140 languages into their open source framework called Transformers. And this is so encouraging and really exciting. And there's a lot more that's going on in the open source community. So it seems like now when researchers release their paper, that same day or a couple days later, there's a few implementations on GitHub that you can run yourself. There's a lot of data that you can gather yourself. And there's a lot of collaboration and communication amongst the open source community that I find really encouraging for this, and hopefully will boost the development of AI for every language. All right, so that was just an introduction to natural language processing in general and current language support and some current trends in natural language processing that I find encouraging for pushing AI to every language. Now I'd like to just share a few examples where you can see people actively working on this, and specifically some examples that SIL and myself are involved in to illustrate some of the efforts where people are pushing AI to local languages. And along with that, I hope to share a couple demos with you, because I know you won't believe anything I say until I actually show you working examples, at least if you're engineers. So I want to make sure that we've got some working examples to show. And so I'm going to do that next, and hopefully provide enough time at the end for a good set of question and answer time. where I can answer your specific questions. Yes. What was that? Sorry. Oh, okay, perfect. Let me just mention a couple of things here, and then I'll point you to some further resources. So one of those things is this effort called Masakane, which I'm involved in, and a bunch of researchers across Africa are involved in to get baselines for NLP tasks for African languages. You can find out more about that specific effort at this link. However, I'd like to maybe jump since we have some time constraints to this example, which is something we're working on at SIL, which is a basic NLP task that I think will hopefully enable people to build apps that support local languages, and that's the problem of language identification. Here, if you look at language identification, which is taking in a specific piece of text and identifying what language is corresponding to that piece of text. The open source solutions that are out there generally support maybe 50 to 100 to 150 languages. We've just released a beta API that supports over 1,300 languages. And I'll just demonstrate that real quick as I end out here. Here I wanted to do a French specific example. So let me go ahead and run the examples before here. I'm just installing some of the current language detection or identification things that are out there from in the Python ecosystem. And then what I'm going to do is I'm going to try to identify these languages. So we've got a number of French languages, including French, but also including Picard and Occitan and Corsican and Breton. And we'll see how each of these systems performs on these languages. And this, I should connect this back to what I said earlier. This is basically a text classification example, right? So I'll define that data. Here I'm going to get the language identification from this beta SIL API, and then compare it to the other entries, and hopefully it'll work. All right, so here we've got the identification of Picard, Occitan, Corsican, Breton, French, and you can see that these are just, for the most part, not supported in these other packages. There's a couple that are right here, but in general, if you're wanting to support local languages in your application, you couldn't rely on these to identify those languages in your input user's text. So that was the example I gave. I was going to give another example of a multilingual chatbot, but I'll save that for another time. And then I'll just end by giving a few resources for people. You can sign up for a free key for this language identification beta if you want at that link. And here's some other links to learn more. Thanks again to the organizers, and appreciate your attention.
Thank you very much, Daniel. Yeah, actually we have a question, but I don't think there are a lot of time to answer. We had a question about the creation of a new model to translation between those forgotten languages. If it was easy for a normal person to create them. What is the state of the art of the algorithm used for that?
Yeah, so I would recommend just a quick answer, going to this this repo from the Masakane group, and they actually have a starter notebook that you can use to train one of these models, and they give a lot of explanation on that. And you can jump into this without knowing a lot about the models and start training models for local languages in this way.
Okay, thank you very much, Daniel, and thank you, everybody. We will be back in 10 minutes with the 2 talks about Delta Lake. Join us in the next stream, And don't forget to fill out the satisfaction survey. See you later. Thank you, Daniel.